A very good morning, my dear students. Welcome to this chemistry digital class. Dear student, as you know that we have already started our unit 14, that is biomolecule. And if I'll say we are almost in the end stage of our syllabus. After that we are going to start our revision. So before going to revise, it is my humble request that you all must know your weak points. You all must know your doubts. Okay, so that by keeping those things in mind, I will start my revision in the best way. Okay, so before going to start today's topic, because I got some of the queries from the students through conference call system, so I just want to clear those doubts first. Okay, so let's start. And the doubt is related to some important compounds of haloalkane and haloarine, which we can say also polyhalogen compounds. Okay, first polyhalogen compounds are what? These are the hydrocarbons which contain more than one halogen from group 17. Okay, so there are basically different compounds: dichloromethane, trichloromethane, formula side by side you can see, tetrachloromethane, iodoform or fruin. So the first doubt that is the student are, that is fruin. Second doubt that student are DDT. DDT is full form dichloro diphenyl trichloromethane. Dichloro, it means that dichloro. So you can see one chlorine is here, second chlorine is here. So dichloro diphenyl, two phenyl ring is there. Trichloro 1,2 ethane. This is the full form. Okay, so one by one I am going to tell. First you were asking about the structure, I think. So this is the structure, this is the structure. Okay, so if I'll tell about the structure, so first thing in the structure that you need to see, the formula. What is the formula? The formula of compound is, suppose, fruin. It is written fruin. The formula of fruin is, first I am going to tell you fruin. First formula of fruin is, it is, as you can see, CCl2F2. CCl2F2. So it means that what is in the center? There is C. Then how many chlorine is there? 1, 2 chlorine and 2 fluorine. As you know that one carbon can make 4 bonds around it. So in which 2 bond is shared by fluorine, 2 bond is shared by chlorine. So this you can make like this way also. Chlorine, chlorine, fluorine, fluorine. It depends. Okay, 2 fluorine together, 2 chlorine together, or 1 chloro, 1 fluoro, 1 chloro, 1 fluoro is there. That is same, both are same. So this is also somewhere I can say one of the very important compound of halogen, polyhalogen. You can see here 4 halogen are there, in which 2 are fluorine, 2 are chlorine. Okay, so structure is tetrahedral. Obviously it is stable, unreactive, non-toxic and non-corrosive, and it is easily liquefiable gas which is produced by a refrigerant. It is the one of the major gas that is produced by refrigerant. Nowadays we are using just to cool our air conditioner, AC. Okay, and for cooling purpose. Similar way, DDT. If I will tell about DDT, already I told you the full form is dichloro diphenyl trichloro ethane. This is the full form of the DDT. DDT. Now dichloro difluoro diphenyl. First you draw dichloro. 1 chloro benzene we have to draw. That will be attached with first carbon of the ethane. Okay. Then other side also 1 phenyl, 1 chlorine. So this side it will be H. Why? Because we need to satisfy tetravalency, 1, 2, 3, 4 valency of carbon. So 2 phenyl, 2 chloro. It will come 2 chloro, 2 phenyl. 2 chloro means dichloro. Dichloro, 1 chloro, second chloro. Dichloro, 2 phenyl, 1, 2. 2 phenyl. Benzene is also called phenyl. Then diphenyl, dichloro, diphenyl ho gaya. Then trichloro. Trichloro will be with this second carbon of the ethane. Okay, this is 1, 2. 1, 2, 3. 3 chlorine, trichloro. Now 1 and 2 carbon is there, ethane. So this is the very simplest structure. And if you will say about its properties, so it is colorless, crystalline, tasteless and almost odorless. It is prepared in 1873 and used as a medicine in 1939 by Paul Mueller. He got Nobel Prize for this also, 1948. Popularly It is against mosquito and lice that carry typhus, but now it is banned in many of the country due to its chemical instability and fat solubility. It is getting soluble in the fat of animal and human, so which can harmful for their body also. So for that purpose it is banned. So this is your doubt, Freeman and DDT. Although this has deducted by board in his 70% syllabus, so still you ask the doubt, and it's my duty to clear this. So now let's start today's topic. So before going to start today's topic, dear student, let's recapitulate what we did from unit 14. We are talking about biomolecule, in which we break bio and molecule. Bio mean living, molecule mean composition of elements. So it is a branch of chemistry which deals with the study of various chemical composition or changes that taking place within the living organism, which is fall under biochemistry. Branch of chemistry deal with the study of various chemical changes taking place inside the living organism body, that is called biochemistry, and the composition of various complexes compound. बहुत सारे ऐसे कॉम्प्लेक्स कंपाउंड है जो एनिमल और ह्यूमन की बॉडीज में है या ऑर्गेनिक लिविंग ऑर्गेनिज्म के बॉडी के अंदर है, जो कंपोज होते हैं, चेंजेस हो जाते हैं. And these compositions such as carbohydrate, fat, protein, nucleic acid are referred as biomolecule. So basically in this chapter we will study about carbohydrate, protein, lipids, nucleic acid. So in carbohydrate there is a carbohydrate in very much detail, protein is very much detail, nucleic acid very much detail, but there is very less reference of fats and lipids. So carbohydrate is what basically? Carbohydrate is the composition of carbon, hydrogen and oxygen. If we will talk about classification, the carbohydrate classified on the basis of number of saccharide. Saccharide means sugar molecule. Monosaccharide, disaccharide, polysaccharide. It's called monosaccharide, oligosaccharide and polysaccharide also. In oligosaccharide, we are talking about those saccharide where is more than two carbohydrates are there, two monosaccharides are there. Okay, so these are the examples. So in yesterday's video we talked about glucose. We study about the structure of glucose, we study about the fructose. Now today we will do fructose, then slowly protein, nucleic acid. Okay, so according to my book, carbohydrate, these are the polyhydroxyaldehyde. polyhydroxyaldehyde मतलब बहुत सारे OH ग्रुप होंगे और CH भी होगा और C double bond O ketone group भी होगा. Okay, carbohydrate are those compound in which many hydroxy OH group is there, aldehyde is there, and ketone group is also present there. So which upon hydrolysis produce such compound. There are different classification. Carbohydrate in generally classified as sugar, which are sweet and water soluble, and non-sugar. Sugar, it is categorized on the basis of sugar and non-sugar. Sugar are sweet in taste and water soluble like glucose, fructose, etc. Non-sugar are tasteless, water soluble like starch, cellulose. So polyhydroxide, polysaccharide are basically non-sugar. These are the compound of non-sugar, and monosaccharide, disaccharide are the compounds of sugar. Okay, these are the compound of sugar carbohydrate. These are non-sugar carbohydrate. Okay, so already we have studied, so I'm not going to tell you. I just want to bring your kind intention toward D and L designation of carbohydrate. Carbohydrate are somewhere named as D and L. So students are getting confused. What is the meaning of D? What is the meaning of L? So dear students, let's understand. The sugar are divided into two families basically. Sugar are divided into two families on the basis of its characteristics. D family, L family, which have definite configuration. These configurations are represented with respect to glyceraldehyde as the standard. The glyceraldehyde may be present by two forms, D-glyceraldehyde, L-glyceraldehyde. So see D-glyceraldehyde, what is happening? It is totally depending upon the position of hydroxide. Again I am telling position of hydroxide. Just focus here, right, left. What? OH. So maybe hint is clear to you. The compound of glucose, if I will draw the structure of glucose, if I will tell you how glucose is representing, basically structure of glucose is C double bond OH. It is aldehyde. 1, 2, 3. Fourth compound is this. Then 1, 2, 3, 4. 1, 2, 3, 4, 5. And sixth one is OH, H, H. So difference is in first carbon and sixth carbon. Difference is somewhere in carbon number 1 and carbon number 6. Okay. And if I will say the carbon number 2, 3, 4 and 5, so there is hydroxide. This is aldehyde, as already we studied that. Carbohydrate are what? Carbohydrate are the poly compounds of aldehyde, in which aldehyde are there, polyhydroxide are there, here polyhydroxy. polyhydroxy mean poly OH group is there. Now it depends which side OH group is there. In case of dextro, if I will tell dextro, okay, so this is alcohol OH. Now see, second OH is right hand side. This is right side. This is left side. And left hand side H will be there. Whereas in case of third carbon, the OH is on left hand side and H is on right side. Whereas fourth and fifth carbon both have OH on right hand side and H on left hand side. And students are getting confused on the only in this. So dear students, it is my direction to you, suggestion to you, always keep like this way. First is aldehyde, second right, third left, fourth, fifth right. What is now right, left? OH group, because you know very well from group number 3 to group number 6 there is only OH hydroxide. Okay, so this become the name of this compound become dextro plus glucose. Okay, dextro plus glucose. Now dextro is what? It is the right hand side. It is the right hand side. Then you will write it on right hand side. Okay, then it is the name of this compound will become dextro glucose. So we will understand. We were understanding dextro and levo. So dextro, you know, when OH is on right hand side, which structure I have drawn, and levo is that glyceraldehyde in which OH is toward left hand side. When OH is toward left hand side, it means that you understood this is levo structure. The dextro configuration has OH attached to the carbon adjacent to the CH2OH. Carbon to the adjacent to the CH2OH. Okay, hope so you understood and you are understanding whatever I am telling. In which again I am telling COH CH2 CHOH, which is OH attached to carbon adjacent to CH2OH. We are talking about this CH2OH. This is CH2OH, you can see, and the carbon which is adjacent to this is this carbon number 5. Okay, we are talking about carbon number 5. If that carbon is attached on the right, while L configuration, in L configuration OH attached to the carbon adjacent to the CH2 is toward the left side. Okay, so here we are discussing about only that OH group number carbon number 5 OH which is adjacent to CH2OH. If that is right hand side, then it is dextro. If that is left hand side, that is levo. The sugar are called D and L depending upon whether the configuration of the molecule is related to D glyceraldehyde or L glyceraldehyde. By convention, a molecule is assigned D configuration if OH group is attached to the carbon adjacent to C. Chiral is the right hand side and levo toward left hand side. On the other hand side, when levo, it is toward left hand side. Okay, so that is the main meaning of D and L designation of carbohydrate. I think it is clear to you now. Now in my last video I told you about glucose, where we studied that glucose can be prepared by two methods. It can prepare from sucrose, it can prepare from starch. That you understood. If you will talk about properties and structure, I know very well some of the students, they were asking about structure. They got confused with the structure. So here today again I am going to tell you the structure. Glucose is an aldehyde and also called dextrose. Dextrose mean it is aldohexose, means 6 carbon ring with aldehyde group. 6 carbon with aldehyde group. Its molecular formula is C6H12O6 and its structure is, this is the structure of glucose. 1, 2, 3, 4, 5, 6. 6 carbon with aldehyde in the first, and third to sixth there is hydroxide. Now it depend again. Third right, fourth left, fifth sixth right, fourth fifth right, second right, third left, fourth fifth sixth right hand side. Okay, now it totally depend upon this carbon. If this OH is toward right, it is called dextro. If this OH is toward left, then it is levo. Only this is the difference. And if we will talk about important reactions, so it convert this glucose when in the presence of HI in direct N-hexane. It will change into N-hexane. It will change into glucose oxime in the presence of amine hydroxide. HCN will give cyanohydrine. Similar way, these are the properties that we have in the previous video. Now this is the same structure, dear students, which structure I have just told you how to draw. This is same structure. You can see first carbon have CHO. Okay? If I will draw this open, this is like this way, CH, then COH, H, CHOH, then COH, 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 H, 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 and H. This is also called CH2OH because in this carbon only there are 2 hydrogen, rest carbon have 1 hydrogen. So this is like this. And one more way of making the structure, all the structures are of same type, only the difference is CHOH4. okay, whether right or left, इसमें कोई वो नहीं है इसका. CH2OH. Sometimes this diagram is written in this way also. So this is also same, CHOH 4 times, 1 2 3 4 times CHOH, CHOH, CHOH is there. If you will draw open structure, then you will come to know which side, right and left side hydroxide is there. And if you will draw with the carbon, then you will come to know how many carbon is there. Okay, so these are the 3 different way of making structure of glucose, but in every structure it is same. Okay, now one word is there, mutarotation. It is the spontaneous change in specific rotation of an optically active compound with time to an equilibrium value, which is called mutarotation. What is mutarotation now? It is a spontaneous change in the specific rotation. अगर इस स्ट्रक्चर को रोटेट किया जाए, घुमाया जाए, and in that rotation, like I told you, if we are rotating like this way, this pencil or pen, so it means that you will see the direction of right and left change, not up down. So when light will fall on glucose, the glucose will somewhere rotate its structure. Just imagine that. Okay, and that is called mutarotation. The pair of optical isomer which differ in configuration only around C1 atom is called anomer. जब एक ही कार्बन पर रोटेशन चेंज हो जाती है, एक ही कार्बन घूमता है, मान लो यही कार्बन घूम रहा है सिर्फ, दिस कार्बन इज ओनली रोटेटिंग, देन इट इज कॉल्ड एनोमर. एंड वी हैव डिफरेंट टाइप ऑफ अल्फा डेक्स्ट्रोग्लूकोज, D glucose open chain, then beta dextroglucose. You can see here, this side on this carbon the hydroxide is on right hand side. If we will say here hydroxide is on left hand side. So this is, it means that only this carbon has rotate. अगर मान लो 6 कार्बन की चेन हो और सिर्फ ऊपर वाला कैप ही हिलाया जाए, if I will take example by moving this cap, suppose this is a glucose carbon and this is the first carbon, and you can see this side, this clip of this cap is toward this side, now toward this side. Then when I will rotate it in this way, and now what will happen? Pen is in same direction, only this cap tip is toward left hand side now. Okay, so same thing happened here in carbon number 1. Rest OH 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 H H H OH 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 CH2O CH2O, and this is change. Okay, so now what will happen? This hydrogen will start making bond with the 5th carbon of hydroxide. This is 5th carbon hydroxide. It will start making bond. It can attack on oxygen. Oxygen will attack on carbon. So in this way it will form CO with H, that H which was here, that, and it convert aldehyde into alcohol. Okay, this is the I can say mutarotation. Dear student, why I am taking this structure of carbon very seriously, glucose very seriously, because this question they are asking so many times, and you must know what is this. Okay, then this is the mutarotation where first carbon, only one carbon is rotating, and it's hydroxide. Now above representation called Fisher projection formula. This representation is called Fisher projection formula. कई बार क्वेश्चन आता है, draw the structure of glucose on the basis of Fisher projection formula. This is Fisher projection formula. You will draw this structure, and in this structure again I am telling you, this is the complete structure in which you can see the 5th carbon where hydroxide is there. That hydroxide will combine with first carbon hydrogen and it will give this structure. Okay, so this structure you will draw. Second is, we have one more projection, that is Haworth projection formula. Haworth projection formula is also called Pyrenees structure. You might studied it in biology also. Pyrenees structure, which is a ring cyclic structure. Okay, now if we will discuss the cyclic structure, now if I will tell the cyclic structure of glucose by Haworth projection, okay, so then you know very well there are 6 carbon. Okay, and the 6th carbon is changed into the 5th number carbon change. So we will make 1 2 3 4 5 6, in which 5th carbon now will attach with first carbon. Okay, and we will get now this type of projection. Okay, H OH OH H, 5th was there, this side OH, so this side H will be there, CH2OH. Okay, OH OH. H will make bond. COH. Okay. So this is like a formula of alpha. This is alpha dextroglucose. If beta dextroglucose we will make, so only one difference is there, dear student, that is difference is here. In place of H there will be OH then. Okay, rest is same. Then beta, in beta there is OH, in alpha there is H. So now you can draw the same thing in a cyclic way. Okay, how you will draw in a cyclic way? First thing, between carbon 1 and carbon 5 there is O. Between carbon 1 and carbon 5 there is O. So O will be made between carbon 1 and between carbon 5. Okay, rest carbon you know very well, 6 carbon is there, to hexagonal ring we will make. Sixth carbon will be CH2OH. This sixth carbon will be here, that is sixth. Rest 4. Now what is the first carbon? In first carbon, H is left hand side, OH is right hand side. The left hand side things we will make up, right hand side things we will make down. Left hand side thing we will make up. You can write sorry, this is right hand side. Okay, right hand side you will write up. Okay, and left hand side you will write down. Got my point? Right hand side you will write up, left hand side you will down. Okay, so now see, if we will draw a left hand side, this alpha carbon, if we are drawing alpha dextroglucose, it's according to Hart projection. The first carbon, H is right hand side and OH is left hand side. The right hand side thing we will make up, left hand side things we will make down. Now second carbon, this is in which OH was right hand side, so it means that OH will be drawn up. Wait, sorry dear students, one small mistake we did. This is H, this is OH in alpha. Okay, in beta both side will change. OH will change here in first also, OH will change in this also. Okay, so don't be confused. Okay, now H, OH, so H will make and OH down. Left side we will make up, left side we will make up now, and right side we will make down now. Okay, please do correction this. Left side, whatever left side is there, that will make up. Whatever right side we have made, that will make down. So right side OH is there, that is down. Left side H is there, that is up. See, H up, OH down. Then in third carbon, OH is left, that will make up, OH is up, and H is down. Fourth, H is up, OH is down. Fifth, H down, CH2OH up. Okay, so this is dextro. And if I will draw beta dextrocarbon, I'm making first beta structure, then I will draw the cyclic ring. Okay, so you know very well there are 1 2 3 4 5 6 carbon. Sixth carbon, you know, CH2OH. First carbon will be connect with fifth carbon, and in beta dextroglucose, fifth carbon, this side there will be OH. Okay, whereas in fourth carbon is same, third carbon is also same, second carbon is also same. First carbon will change, this side now it is OH, this side it is H. Okay, this is beta. Now same thing we will make here. You know very well, first carbon and fifth carbon. Between first carbon and fifth carbon there is oxygen. Sixth carbon is CH2 attached with carbon. Now we will draw all the other carbon. Now first carbon, in first carbon H is right and left. So what I said, left side we will draw up. Now OH up, H down. Second, H up, OH down. Third, OH up, H down. Fourth, OH is right hand side, that will be down, and H is left hand side, that will be up. Okay, and in fifth number carbon, H is down. In fifth number carbon, H is, yes, down. Okay, so dear student, these are the alpha and beta dextroglucose. And question in exam will come, draw the structure of alpha dextroglucose, beta dextroglucose on the basis of Fischer projection. Then you will draw these two structure. If question will come, draw the cyclic glucose by Hart projection, then you will draw these two structure. Okay, so this is all about glucose structure that we have done. So this again I have drawn, but because some of the students, they were asking doubts. Now second is fructose. if I'll tell about fructose, the one difference is there in fructose only. The structure is C6H12O6. Same formula is there. It is polyhydroxy and ketonic group. So see, dextro negative fructose now. 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon. It means that first carbon is now CH2OH. In this first carbon was aldehyde, glucose. Here first carbon is CH2OH. Second carbon is ketone. Okay, the fructose and glucose. The difference is aldehyde and ketone. In glucose there is aldehyde group, whereas in fructose there is ketone group. It is the ketonic group of carbohydrate. It is ketonic group of carbohydrate. So at number 2 carbon there is double bond O, then 3 carbon right hand side H, left hand side OH. Fourth and fifth again OH, fourth, fifth, as it was in glucose. Sixth carbon again CH2OH. Okay, so this is structure. If you will see with the glucose, like glucose, this is the glucose structure. Like glucose, fructose will also be like glucose, fructose will also having Fischer structure. So see here, second number carbon. Now in glucose, first number carbon attached with fifth number carbon, whereas in fructose, second number carbon will attach with the sixth number of carbon. Okay, this is the difference. So CH2OH will remain same. Second number carbon will attach like this with OH, and the bond of hydroxide will become from here. That's why it has pentose ring, not hexose. And Horth structure will you can draw. So practice today this. Okay, and this is all about monosaccharide. So if still you are facing any problem, so you can ask me. Okay, so this is all about. Thank you very much for today's class. And dear students, once again, more and more practice you will do of this structure, you will get more. And these are very simple, as I told you. Just you need to see carefully in which carbon hydroxide is which side and hydrogen is which side, and which carbon is linked with which carbon with the help of oxygen, so that it will convert Fischer structure into Horth projection. Okay, the projection means how it is representing. Okay, so okay then, ठीक है, tell you, take care yourself and stay home, stay safe. Thank you. Thanks for watching this video. Thank you.